In this video, we will solve Mathematics Paper 1 Variant 2 for October-November 2020. So let's start with question number 1. Part A is evaluate 4 over 5 minus 2 over 3. So we can take the LCM of 5 and 3. Since they do not have any common factors, we can simply multiply them together. 5 3s are 15, so your LCM is 15. So this 4 will also be multiplied by 3, will become 12, minus 2 will be multiplied by 5 since 3 was multiplied by 5 in the denominator. So this will be 2 times 5 will be 10. So 12 minus 10 is 2 over 15. Part B is evaluate 2.7 multiplied by 0.2. So I can convert these into fractions to remove the decimal. So 2.7 will become 27 divided by 10 multiplied by 2 over 10. So 27 multiplied by 2, 7 2s are 14, 1 carry 54. So this will be 54 divided by 10 times 10 is 100. So 2 zeros, so I'll move the decimal 2 places to the left. This will be 0.54. Question number 2 is find the fraction which lies exactly halfway between 3 over 5 and 5 over 7. Give your answer in its simplest form. So to find the fraction halfway between these two, we will add them together and then divide by 2. So 3 by 5 plus 5 over 7, and then you will divide the answer by 2 to get the value in the middle of the two fractions. So again we will take the LCM, which will be, again 7 and 5 do not have any common factors, so this will be 7 times 5 35, 7 times 3 will be 21, 5 times 5 will be 25 divided by 2. So this will be 46 over 35, and I can convert this division sign into multiplication, and I will take the reciprocal, so this will become 1 by 2, and 2 times 1, 2 times 2, and 3, so this will be 23 over 35. Question number 3 is you have to factorize 12t square minus 4t. So I can take 4t common, so I'm left with 3t here and just 1 here. So this will be 4t multiplied by 3t minus 1. Part B is a times x minus y plus b times y minus x. So now you can see that this is x minus y, but this is y minus x. So to change the signs to have the same x minus y here, I will take the negative sign outside, and this will flip the sign of x and y inside. So a times x minus y as it is, and now I will have minus b, and since I took minus outside, the signs inside the bracket will change. So this will become plus x and this will become minus y. And now I can take x minus y common, so this will be a minus b multiplied by x minus y. Part C is x square minus 2x minus 3. So you have to factorize this. What you can do is you take the number which is minus 3 here and multiply it with the coefficient of x square, which is 1 here. So minus 3 multiplied by 1 is minus 3. Now you have to find the factors of minus 3. Since this is negative, so you have to find two factors whom if we subtract you get minus 2. So if I look at factors of 3, these are only 3 and 1, right? So if I do minus 3 plus 1, or if I do 1 plus 1 minus 3, if I multiply them together, I get minus 3. Minus 3 times 1 is minus 3, or 1 times minus 3 is minus 3. And if I subtract them, I get this middle number, which is minus 2. So I can use these two factors and subtract them to get minus 2. So I can write x square and I can write minus 2x as uh, plus x, which is 1x, and then minus 3x and then minus 3. So x minus 3x is minus 2x. Now I can take x common here from the first two. So this will be x into x plus 1 and minus 3 common here. So this will be x plus 1 as well. So this sign will change to positive because I took negative outside. So this will be x plus 1 into x minus 3. So x plus 1 into x minus 3. Question number 4 is write these lengths in order of size starting with the smallest. So now you have some values in kilometers, this is in centimeter, this is in millimeter, so and this is in meter. So we need to first convert them to the same unit so that we can compare them easily. So let's convert everything, I think, to centimeters. So this will be, I multiply it by 1000. So I'll move the decimal 3 places to the right, 1, 2, 3. That will give me 43 meters. And then I can multiply it with 100 to get the centimeters. So this will be 4300 centimeter. This will be as it is 433 centimeter. And then I can divide this by 10 to get centimeters because 1 centimeter has 10 millimeter. So the decimal will move here. So this will be 434 centimeter. And 4 whole 1 by 3 is 4.33333 meters. These threes basically continue forever, and then meters. So now to convert it into centimeter, I will multiply it by 100. So the decimal will move 2 places to the right. So this will be 433.3333 and so on centimeters. So 433.3333 centimeters. Now we can do the comparison easily. So 433 centimeter is the smallest value and it is represented by 433 centimeters. So I will write 433 as the smallest. And then I have this value, which is 433.333 centimeter, which is the next biggest value. It is represented by 4 whole 1 by 3 meters. So this is done, this is done. And then you have 434 centimeter, which is the next biggest value, which is represented by 4340 millimeters. And then the largest value is this one, which is 4300 centimeters. So this is represented by 0.043 kilometers. So this is how you will arrange them from smallest to largest. Question number 5 is Sandra buys a vase for $40 and sells it for $200. Calculate her percentage profit. So let's first calculate the profit. Profit will be the sale price, which is 200, minus the price at which Sandra bought the vase, which is $40. So sale price minus purchase price is your profit, which is $160. Now to calculate percentage profit, this will be your profit divided by the purchase price, which is $40, and then multiplied by 100 to calculate the percentage. So 0, 0 cancel out, 4 times 1, 4 times 4, and then this is 400%. So your answer here will be 400%. Question number 6 is, these are the minimum temperatures in degrees Celsius recorded by a weather station each day during 1 week. Find the range of these temperatures. So the range will be the max value minus the minimum value. So the maximum minus minimum will be your range. So what is the maximum value? So the maximum value here is minus 0.7 since all the values are in negative. So this will be your largest value, which is minus 0.7 minus the minimum value. So minimum value here is this one, which is minus 4.6. So minus 4.6. So this will be minus 0.7 plus 4.6. So 4.6 minus 0.7 will be 3.9. So your range is 3.9 degrees Celsius. The next part is how many of these temperatures are between -4 and -2 degrees Celsius? So if you draw the number line, you have -4, -3, -2, -1, 0, 1, 2, and so on. So you're looking for temperatures between -4 and -2. So any number that lies on the number line here between -4 and -2. So let's start with the first one, which is -2.3. So -2.3 will be somewhere here. So this number is in our range. -4.6 will be somewhere here. So this is not in the range. -1.2 will be here. -0.7 will be here somewhere. -1.4 will be here. -2.4 will be somewhere here. So this is also within the range. -3.5 will be here in the middle between -3 and -4. So this is also in the range. So how many are in this range? 1, 2, 3. So there are three values that are in the given range. Question number 7 is, by writing each number correct to one significant figure, estimate the value of this. So when you start looking from the left side, your first non-zero value is 6. So this will be, and the next value is 0. So this will be rounded down to 0. So 6 square, oh sorry, rounded down to 6. So this will become 6 square. This is our first non-zero value. The next value is 1. So 2 will be, 212 will be rounded down to 200, multiplied by, this is our first non-zero value. The next value is 0. So 0.3, this 3 will remain as it is. So this will become 0.3. So 6 square is 36 divided by 200 into 0.3. 2 times 18 and 2 times 100. I can divide by 2 on both in the numerator and denominator. 0.3 multiplied by 100. So this decimal will move 2 places to the right. So this will become 18 over 30. I can divide by 6 in the numerator as well as the denominator. So this will become 6 threes are 18 and 6 fives are 30. So this will be 3 over 5. Question number 9 is, in the diagram, the time on the clock is 2:30 p.m. Calculate the reflex angle between the two hands of the clock. So your reflex angle is greater than 180. So the reflex angle is between 180 and 360 degrees. So the reflex angle between the two hands of the clock is this angle, which is between 180 and 360 degrees. So if I extend this arm upwards here like this, I know that this angle will be 180. So let me mark it in green. So this angle is 180 degrees. And then if I can find this red angle, green plus red will give me the reflex angle that I'm looking for. So let's try to find this red angle here. So if you look at this clock, your needle starts at 12 and it goes around the full circle 360 degree in 12 hours, right? So if I take hours and ratio degrees, so 12 hours represent a full 360 degree rotation. And now we are interested in how many hours. So the time is 2:30 p.m. That means that this hand is right in the middle between 2 and 3. So it's right in the center of 2 and 3. So 1, 2, and 2.5. So you are interested in 2.5 hours, like how many degrees represent 2.5 hours. So let's call them X. And now since they are directly proportional, more hours mean more degrees. So if you have 5 hours, your degrees will be this much. And if you increase your hours to 8, you'll have more degrees in your circle. So since they are directly proportional, I can cross multiply. So this will become 12x equals to 360 multiplied by 2.5. So x will be 360 multiplied by 2.5 divided by 12. So 12 times 1, 12 times 3 is 36 and 0. So this will become 30 multiplied by 2.5. I can use this 0 to move this decimal one place to the right. So this will become 3 into 25, which is 75 degrees. So this red angle here is 75. So now your reflex angle between the two hands will be 180 plus 75, which is 255 degrees. So the answer here will be 255 degrees. Question number 9, part A, simplify this expression. So I can open the brackets, multiply this 3 inside. So this will be 3 times 3, 9a, minus 4 times 3 is 12, plus 4 minus 2a. So 9a minus 2a will be 7a, minus 12 plus 4 will be minus 8. So your answer is 7a minus 8. Given that 4x equals to 3y, find the numerical value of this. So you're given here 8x, you're given 4x equals to 3y. So if I multiply by 2 on both sides, on the left hand side and the right hand side, I will get 8x equals to 6y. So now I can substitute this 8x with this 6y. So I will get 6y plus y over y. This will be 7y divided by y. Y and y cancel out and you get value 7. Question number 10 is solve the simultaneous equations 3x minus 2y equals to 12, 4x plus y equals to 5. So this is equation 1, equation 2. So from equation 2, I can make y the subject. So y will be equals to 5 minus 4x. And now I can substitute this value. So I'm using the substitution method. I will substitute the value of y in equation 1. So 3x minus 2y. And in place of y, I will write 5 minus 4x equals to 12. So now we can solve this. This will be minus 10, minus and minus plus 8x equals to 12. 8 plus 3, 11x. And this 10 goes there, it will become positive. So this will be 22, x will be equals to 2. Now we can substitute the value of x in this second equation. So 4 times 2, which is x here, plus y equals to 5. So this is 8 plus y equals to 5. So y will be 5 minus 8, which is minus 3. So x is 2 and y is minus 3. Question number 11 is express 340,000 in standard form. So we have to bring our decimal to this point. So that means we have to move it 1, 2, 3, 4, and 5 places to the left. So this will become 3.4 into 10 power positive 5. So when you move the decimal towards the left, your powers of 10 will increase. So 3.4 into 10 power 5. Part B is evaluate this, giving your answer in standard form. So 4 into 10 power 7 divided by 8 into 10 power 21. So 4 times 1 is 4, 4 times 2 is 8. I can cancel these out. So this will become 1 by 2 into, so since this 10 power 7 is being divided by this 10 power 21, the powers will be subtracted. So 10 power 7 and this will become minus 21. So 1 by 2 is 0.5 multiplied by 7 minus 21 is 10 power minus 14. So right now this is not in standard form. This value should be greater than equal to 1. So I will move this decimal one place to the right. So this will become 5. And since I moved it to the right, I will decrease the power of 10 by 1. So minus 14 minus 1 will be 10 power minus 15. So your answer will be 5 into 10 power minus 15. Part C is you're given this, find the value of k. So let's simplify the expression on the left hand side here. I can take 10 power a as common. It's present in both. So 10 power a. And then I'm left with 7 multiplied by, I've taken 10 power a outside. So this will be just 1. And then minus 3 into, I've taken 10 power a outside. So I'm left with 10 power minus 1. So this will become 10 power a. 7 times 1 is 7 minus 10 power minus 1 means 1 over 10. So this will become 3 over 10. So 10 power a 7 minus 0.3. So this will be equal to 10 power a. 7 minus 0.3 will be 6.7. So this is the left hand side. So let me write it down in this form, which is 6.7 into 10 power a, and the right hand side is k into 10 power a. Now we can see that there are same values on each side of the equation. You have 10 power a and 10 power a. So that means the value of k should be equal to 6.7. So k is 6.7. Question number 12, part A is simplify this. So I can bring the power inside. So that means the power 3 which I bring inside will be multiplied with the power of 2 and x. So power of 2 is 1 inside. So 1 multiplied by 3 is 3. So 2 power 3. And then multiplied by x squared. And then I bring this 3 in. So it will be multiplied in the power. So this will become 2 power 3 is 8. 2 cube is 8. And then this will be x power 6. So 8x power 6. Part B is simplify this. So I can write it down as 60 cube divided by, so this is actually 2t squared over 3. So this t square is in the numerator. Now I can change this division sign into multiplication, and I will take the reciprocal, so 3 over 2t square. So 2 times 1, 2 times 3, t square will cancel out, and this will be left with t power 1. So 3t multiplied by 3 will be 9t. So this answer here will be 9t. Question number 13, part A is you're given two sets P and Q. Find the number of elements in P union Q. So let's first find what is P union Q. So P union Q is everything in P and everything in Q, except you don't write the same number twice. So there's no duplication. So let's first write everything down that is in a set P. So you have 1, 2, 3, 4, 5, 6, 7, 8, 5, 6, 7, 8. So this is everything in P, and then let's write down everything in Q, but make sure we don't duplicate. So we have already written 1, you have already written 3, 5 is already there, 7 is also there, 9 is missing, so 9 and then 11. So this is the set P union Q. Now we have to, the question asks for the number of elements in this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 elements, so the answer is 10. Part B is you're given PQR. On the Venn diagram below, write each of the letters P, Q, and R in its appropriate subset. So P is what? A intersection B. So what is the area that is overlapped with A as well as B? So this is this area. This is A intersection B. So your P will be here. The next one is A union B complement. So what is A union B? A union B is everything inside A and everything inside B. So this blue boundary, everything inside this blue boundary is A union B. But Q is outside because you have this complement. So A union B complement means everything outside of this blue boundary. So you can write Q anywhere here. So let me just erase this. And the next one is R, which is A intersection B complement. So B complement, this is B. Everything outside this is B complement, right? And now you have to find the intersection of B complement with A. So what is the overlapping area of B complement with A? It is, let me mark this in red. So this is the, everything inside here is part of A and also part of B complement, which is everything outside B. So this is your R. So let me just erase this and write R. So this was P and this was R. So question number 14 is this net is folded to make a triangular prism. Part A is which vertices join with A. So A is this point here. So what I'll do is I'll rotate this image a little bit and try to create a 3D view from this net of the prism that we will create from this net. If you can visualize on how you can create your prism from the provided net, that is fine as well. But let me actually go through the process of creating the prism so that it's easier to visualize. So let me redraw this a little bit, tilt it like this. So, and then I'll label the points as well. So this is E, D, C, F, G, H, J, B, A, and K. So now let's fold this net into a 3D prism. So I'll start with this triangle on the top. I will rotate, or in fact, I will fold it on this edge, FH, and bring this upwards into a vertical triangle. So let me actually draw this. So imagine like this is a 3D shape. Now this triangle is vertically standing rather than laying flat on the floor. So, and this angle will be 90-degree, which is this angle here in the net. And then similarly, I will fold on this edge CJ and fold it upwards into a vertical standing position as well. So let me draw that as well. So this will be 90-degree angle as well. And once I fold on this JC and bring this triangle upright, this rectangle here will come along as well. So this will be like this, something like this. In fact, they'll be like same length, a little bit less maybe, since it's folded upwards. So now my A, which was here, has gone up here. B, which was here, has gone up here. C and J remain here, so I can erase this since I've folded it upwards like this into a vertically standing position. So now this is starting to look like a 3D triangular prism. All right. So now I have the two sides. Now I can fold this back side, this back rectangle like this to form this back side of the prism. So that means I'll rotate it like this. So it will come here, somewhere here like this. And then I'll keep rotating until I make it to the back of the prism. So my final position of this rectangle will be like this. So this BA is now this BA. So both A and G will join here. So now let me erase this. And this K, uh, yeah, so this was K. This will be at the bottom here with H. So this was K, this was A, and I kept rotating until I ended up here on the back side of the prism. So this was A, and the bottom one was K. So H and K will meet here, A and G will meet here. So let me just erase this as well. So this is J, and I can erase all of this. All right. So now the only side of the prism left is this front side. This is empty. So I have this side wall, this right wall, this back wall as well. The front side is still open. So that means I will fold this in this direction in 3D. So it will be like this at one point, and then I'll keep moving it until I end up on this front face of the prism. So that means this E will come and join at this point. So this will be A, G, and E. And this D will move and join this point at the top with B. So this will be B as well as D on the top here. So I can just erase this now. F will remain there. And so now I've closed the front side of the prism as well. So if you can't visualize straight away by using the net, you can create your prism from the given net, and now it will be much easier to answer our question. So the first part is which vertices join with A. So with A here, we were joined with G and E. So this will be G and E. Which edge joins DE? So DE was this edge here. So that became the front, the face that I folded from the front. It came to the top here, and it was joined by this AB. So remember this AB that I joined from the back. So this edge AB joined with this edge DE, which I folded from the front. So both the edge DE and BA or AB, whatever you want to call it, they met at the top here. So your answer here, in fact, I can leave it as it is. So this BA came from this side and DE came from this side, and they met at the top here. So your answer, which edge joins DE, your answer will be BA, or you can write AB as well. Both are correct answers. So part C, so let me actually erase this now. We no longer need these. This is F. So part C is FH equals to 2 centimeter. So FH is this length here, the base of this right angled triangle. So this is 2 centimeter, and GH is also 2 centimeter. So GH is this vertical height. GH is also 2 centimeter. Remember, this is a 90-degree angle here, which was this angle here. So this is a right angled triangle, which is the cross section, or you can say the base of this prism. So with base length 2 centimeter and height 2 centimeter as well. And then the last length given is JH is 5 centimeters. So JH is this one. This is 5 centimeters. Find the volume of the triangular prism. So the volume will be given by the area of triangular base multiplied by the height of the prism. So what is the area of the triangular base? So we know that the base length is 2 centimeter, height is 2 as well. So area of a triangle is 1 by 2 into base into height. So 1 by 2 into 2 into 2 multiply by the height of the prism, which is this height, 5 centimeters. So 5 twos are 10, 20, and then 10. So your volume of the triangular prism is 10 centimeter cube. So if you can visualize this prism straight away from the net, then you can answer the question directly as well. Otherwise, you can create the prism from the given net like I did, which makes it easier to answer these first two parts as well as the last one as well. Question number 15 is two bags contain beads. The first bag contains 7 beads, 3 of which are red, 4 are white. The second bag contains 5 beads, 2 of which are red and 3 are blue. One bead is taken at random from each bag. the tree diagram is shown below. So in the first bag, you have total 7. 3 are red, so your probability of red is 3 over 7, and then 4 are white, so your probability here is 4 over 7. And similarly for second bag, total are 5 beads, 2 are red, so your probability is 2 by 5 for red, and then 3 by 5 for blue. So you pick for one bead from the first bag, and then you pick one bead from the second bag. So you're given all the possible outcomes here. So if you pick red, what are the probability of red and blue from the second? And if you pick white from the first, what are the probabilities of red and blue from the second bag? So part A is find the probability that both beads are red. So both beads are red, which means probability of getting red and red, which means probability that you get. So let me actually rewrite this as probability that you get first red, which is from the first bag, and you get second red as well. So once you pick from the first bag, you get a red. And then when you pick from the second bag, you also get a red. That is when your both beads are red. So that means probability of first red, and since there is an and, we will multiply first red and multiply by probability of second red. So what is the probability that you pick red from the first bag? It's 3 over 7. And what is the probability then? So you come this path on this path, and then you'll go this way for the second bag, which is red. Probability is 2 by 5. So this is 6 over 35, your answer. Both beads are white, so that means probability first white and second white as well, similar to how we did it for red. Again, this will be probability of first white multiplied by probability of second white as well. So what is the probability that you get white from the first bag, which is 4 over 7, multiplied by probability of second white. So second bag doesn't even contain any white beads. It only has red and blue. So probability of getting a white from the second bag is 0. So 4 by 7 multiplied by 0 is 0. So there is no way that both beads are white if you pick one bead from the first bag and one bead from the second bag. Part C is probability that you get exactly one bead and that is red. So how can you get exactly one bead which is red? So let me erase this. So you can get one red if you have first red and second blue, or you can also get one red if you have first blue, oh sorry, first white. First bag doesn't even have blue. So first white and then second red. So basically, if you go down this path, you pick a red from the first bag and then you pick a blue from the second bag. Or if you pick white from the first and then red from the second. In these two scenarios, you have exactly one red bead. So let's calculate this. So probability of exactly one red will be equal to, you get probability red. So what was it? Red, blue, white, red. So you get red and then blue, or you get probability of uh, first bag has white and then second bag red. So this is probability of first red and second blue, or probability of first white and second red. So when you have and here, so this is red and blue, you will multiply these. So probability of red and blue, 3 by 7 multiply by 3 by 5. So this will be 3 by 7 multiplied by 3 by 5, or means add probability of white and then red. White and then red. So 4 by 7 multiplied by 2 by 5. 4 by 7 multiplied by 2 by 5. So this is 9 over 35 plus 8 over 35, which is 17 over 35. So this will be your final answer, 17 over 35. Question number 16 is the heights of a sample of plants were measured. The results are shown in the table in the histogram. So you have 15 plants with height between 5 and 10, 25 plants with height between 10 and 15, and so on. Use the histogram to find the value of P. So your histogram, on the y-axis you have frequency density. So frequency density is equals to the frequency divided by the class width. So here we have P frequency for interval 15 to 25. So 15 to 25, your frequency density is 4. So I'll substitute 4 here. Your value of frequency is P. So this will be P. And what is your class width? Your class width is 25 minus 15, which is 10. So from this equation, P equals to 40. Part B is complete the histogram. So the only bar missing is the last one here. So frequency density. So let me actually calculate the frequency density here. So frequency density for this one will be frequency, which is 30, divided by class width, which is 40 minus 25, which is 15. So 30 divided by 15 is 2. So frequency density from 25 till 40 will be 2. So this will be your last bar in the histogram. Question number 17 is the diagram shows the positions of three boards A, B, and C. So A, B, and C. By measurement, find the bearing of B from A. So B from A, your bearing will be this angle here. So if I can calculate this angle, since my protractor is only up till 180 degrees, so I can easily calculate this green angle. And if I subtract this green angle from 360 degrees, I will get this blue angle, which is my bearing of B from A. So let me use my protractor here and center it at A. So the green angle, so this is 0 and this line here is passing through 30 degrees. So this angle here is 30 degrees. So your bearing will be 360. So bearing of B from A will equal to 360 minus 30, which is 330 degrees. So your answer here will be 330 degrees. So the next part is CX is the bisector of angle ACB. So CX, this line here, is the bisector of angle ACB. So that means it divides this angle into two equal halves on the top and the bottom. And all the points on this line, which is the angle bisector, they will be equidistant from line CB and line CA. So part 1 is using compass and a straight edge only, construct the locus of points inside triangle ABC that are equidistant from B and C. So this is your line BC, so that means you have to draw the perpendicular line bisector of this line BC to find the locus of points that are equidistant from B and C. So to draw the perpendicular line bisector, I will center my compass here at C, and then I have to make sure that I open up my compass more than half the length of the line. So more than half the length would be this much, and then I'll draw two arcs on both sides of my line BC. So one arc here and oops. So let me redraw this arc. I changed the length accidentally. So let me redraw the arc. So one arc here and then another arc on this side. And then without changing the length of the compass, I'll center it on B now and then draw arcs on the either side. So I'll have to extend this arc to get the intersection point. And for this one, I'm fine. So let me place it back here at C and then extend this one a little bit further like this. So now, since I have to draw the locus only inside the triangle, I can align my ruler here between the two arcs like this, extend it a little bit, and then just draw the line only inside the triangle. So let me, so I'll have this ruler aligned now, and I can draw only inside the triangle ABC. So this blue line will be a locus of points inside triangle ABC that are equidistant from B and C. So part 2 is a ship is nearer to AC than to BC and nearer to C than to B. Shade the region in which the ship is situated. So if I go back to my triangle here, so the first is it is nearer to AC than to BC. So that means it is below this angle bisector line here. So it's below this black line. And then the second one is it's nearer to C than to B. So that means it is below this blue line as well, which is the perpendicular line bisector of line BC. So if it's closer to C, it should be towards this side. And if it's closer to AC, it should be below this line CX. So this will be the region that you will shade in which the ship is present. So all this region, anywhere, any point in this region will be closer to AC compared to BC, and it will be closer to C compared to B. Question number 18 is the diagram is the distance time graph of Safira's journey from home to a shop and back again. She leaves home at 8:15 and returns at 8:50. So she leaves here at 8:15 and comes back at 8:50. So if you have uh, home and then shop, so she travels a distance of 1200 meters. That means she goes this way 1200 meters and then comes back. So part A is how many minutes does she stay in the shop? So she stays in the shop between 8:30 and 8:35 because the distance is not changing. So here she is walking towards the shop. So her distance from home is increasing, and then it's stable here. That means she spends this much time at the shop and then she starts to come back. So her distance from home starts to decrease until it becomes zero again, which means she's back at home. So she stays at the shop for 5 minutes. At 8:30, her brother leaves home and goes to the shop. He walks at the same speed as Safira. On the grid, draw the graph of his journey to the shop. So he leaves at 8:30. So that means he leaves at this point, his distance is 0. And then he walks at the same speed as Safira. So that means the gradient of her brother's journey will be the same as the gradient of this line because they have the same speed. So this is distance and time. So gradient of distance time graph is speed. So since the gradient is same, I'll draw a straight line from 830 to 1200 with the same gradient. So that means every 5 minutes, her brother will also cover a distance of 400 meters. So in 5 minutes, 400, and the next 5 minutes, it goes from 400 to 800. So every 5 minutes, her brother will cover a distance of 400 meters. So if he starts from here, he will be at 400 meter after 5 minutes, another 400 meter after another 5 minutes, and then another 400 meter after 5 more minutes here. So these points represent the straight line. So let me draw this. So this is her brother's journey to the shop. He'll reach the shop at 8:45. Part 2 is how far is he from the shop when he meets Safira? So this is their meeting point when both of them are at the same distance from the home. So at this point, Safira is coming back in this direction and she is 800 meters from home. If you look at this graph, the distance here is 800 meters. So that means this distance is 800. So let me actually write it down in a different color. So this distance is 800 meter and this distance is 400 meter from the shop because the total distance is 1200 meters. So she's traveled 400 meters back from the shop, and her brother, he's at 800 meters from the home. So 800 meters from the home going in this direction while Safira is coming back, and they cross each other at this point at 8:40. The time is 8:40 and their distance from the home is 800 meter and their distance from the shop is 400 meters. So we are interested in the distance from the shop. How far is he from the shop when he meets Safira? So distance from the shop is 400 meters. Part C is calculate the speed Safira walks to the shop. Give your answer in kilometers per hour. So your speed will be distance divided by time. So we can take the total distance, so her between these 2 points, to calculate the speed. So the total distance traveled is 1200 divided by, in fact, let me convert this into kilometers. So 1200 meters, since we are interested in speed in kilometers per hour. So this is 1.2 kilometers. So 1.2 divided by the time taken. So total time between these 2 points is 8:15 to 8:30. So that means 15 minutes. So time is 15 minutes, which is 15 over 60. I've divided by 60 minutes to convert it into hours. So this is actually 15 times 1, 15 times 4. So this is 1 by 4 hour. So this is divided by 1 over 4 hour, which is our time. And then I can convert this into multiplication sign and take the reciprocal. So 1.2 times 4 will be 4.8 kilometers per hour. So this is her speed walking to the shop, 4.8 kilometers per hour. Question number 19 is triangle A and triangle B and the point P minus 2 and plus 2 are drawn on the grid. Part A1 is describe fully the single transformation that maps triangle A onto triangle B. So the size of the two triangles is same. So this is not an enlargement. This is also not translation because the orientation of the triangle has changed. in translation you only move the triangle around, you don't change its orientation. Can it this be a rotation? So if I start to rotate it like this, I'll get something like this and this and this and then back to A like this. So this is not also not a rotation. So since I don't get this triangle B if I try to rotate triangle A, so this could be a reflection. Now we have to find the line of reflection. To do that, I can join any two corresponding vertices of the triangle, and the midpoints will give me the line of reflection. So if I join this with this corresponding vertex is this here in B. This point is mapped onto this. So this. So now the midpoint is this here and this here. So both of these midpoints, if I join them together, I get the line of reflection, which is basically the x-axis. So this is a reflection in x-axis. Part 2 is write down the matrix that represents this transformation. So we can use the technique that we have learned to calculate the transformation matrix. So you take 2 points. Let's call this A, which is 1 and 0, and then B, which is 0 and 1. And then you apply the transformation. So your object here is your 1, 0, which is A, and 0, 1, which is B. And once you apply the transformation, the resultant matrix is the matrix that represents this transformation. So what happens to A if I reflect it in x-axis? Since this is already on the line of axis, line of reflection, A will not move anywhere. So A prime will also be 1, 0 after reflection. So you have 1, 0 still. And what happens to B if I reflect it in x-axis? It will move down here and this will become 0 and -1. This is B prime. So B is mapped onto B prime and the coordinates are 0 and -1. So 0 and -1. So this is your transformation matrix. 1, 0, 0 and -1. Part B is triangle A is mapped onto triangle C by an enlargement, center P and scale factor -1/2. On the grid, draw and label triangle C. So you're doing an enlargement, scale factor -1/2, and your point or your center of enlargement is uh, point P here, and you're doing the enlargement on triangle A. So to do the enlargement, I will join each vertex of triangle A to my center of enlargement. So like this. So this vertex, since the enlargement, the scaling factor has a negative sign, so that means I have to continue on the opposite side of my center of enlargement. And since the enlargement scale factor is half, I will go half the length of this length red line here, which is 4 squares. So I will move 2 squares, which is half of 4. So half the distance. So you calculate the distance from vertex to center of enlargement, and then you go half the distance because your center of enlargement is half, and you go on the opposite side since there is a negative sign. And then similarly, I'll join this point as well. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So half of this will be 5. 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 8. So this is 8, the distance from this vertex till center of enlargement. So this is 8, and then I'll go 1, 2, 3, 4. So this point is mapped onto this point. And similarly, I will join this third vertex with the, oh, this is not the center of enlargement. I keep confusing. This is P is my center of enlargement. So this is how I will connect this vertex with my center of enlargement. And You measure this distance. So if I measure this with the ruler that I have, this distance is almost 5 centimeters. So I will go 2.5 centimeter in the other direction. So 1, 2, and 2.5 is this much. So this point will be this distance from P up till this point is 2.5. So this is how you will do this enlargement. And now I have all the three vertices. I can join them together to get my triangle C. So this will be your triangle C. Question number 20 is the diagram shows a sequence of patterns, pattern 1, 2, 3, and 4. Each pattern has one more row and two more dots in each row than the pattern before it. So you add, so you have two rows here, you have three rows here, and then you have four rows here. And then you add two dots to each row. So you have one dot, then you have three, then you have five. On the diagram, draw pattern 4. So there are 1, 2, 3 squares, 1, 2, 3 squares in between. So 1, 2, 3. So my pattern 4 will start from here. So I will have one more row. So 1, 2, 3, 4, and then one more row, 5. And each row has two more dots. So 1, 2, 3, 4, 5 dots in this row. So 7. 1, 2, 3, 4, 5, 6, 7. So I'll have 7 dots in the row here. So now I can complete this with the rest of the dots in between. So part B1 is complete the table for the first 4 patterns in the sequence. So in pattern 4, your number of rows, you have 1, 2, 3, 4, 5 rows. In pattern 3, number of dots in each row. So in pattern 3, you have 1, 2, 3, 4, 5. So this will be 5 dots in pattern 3. And then pattern 4, you have 7 dots in each row. So 7. Total number of dots. So in pattern 3, you have uh, 5 in this direction and 4 in this, right? So instead of counting all these, I can just simply multiply these. 5 times 4, 20. And similarly, 7 in this direction, 5 in this. So 7 times 5, 35. Part 2 is find an expression in terms of n for p. So what is p? P is the number of rows in your nth pattern. So if you look at pattern number 1, you have 2 rows. Pattern number 2, you have 3 rows. Pattern number 3, you have 4 rows. Pattern number 4, you have 5 rows. So each time your number of rows is actually one more, plus 1, plus 1, plus 1. So number of rows is one more than the pattern number. So if you have pattern number n, you plus 1 to get p, which is n plus 1. So in your nth pattern, you will have p rows. Next part is find an expression in terms of n for q. So q is what? Q is the number of dots in each row. So let's call it d. So d1 is the number of dots in each row for pattern number 1. You have 1 here. d2, you have 3, which is 1 plus 2. You'll see that the difference is constant, plus 2, plus 2, plus 2. So in d3, uh, in pattern number 3, the number of dots in each row is 5, which is 1 plus 2 plus 2. So this is 1 plus 2 times 1, 1 plus 2 times 2, and d4 is 1 plus 2 plus 2 plus 2, which is 1 plus 2 times 3. So you have 3 2's here. So 1 plus 2 times 3. So for nth row, uh, you will have So if you look at this number here, 2 is being multiplied by 3 in the fourth pattern. So there are 3 2's in fourth pattern. There are 2 2's in 3 pattern. There are there is 1 2 in second pattern. So each time the number of 2's here is 1 less than the pattern number. So this is 1 plus 2 times pattern number n, so n minus 1. So this number is always 1 less than this number here. So this will give you 1 plus 2n minus 2, which is 1 plus, so minus 2 plus 1 will be minus 1. So this will be 2n minus 1. So your answer here is 2n minus 1. Part 4 is find an expression in terms of n for the total number of dots in pattern n. So for total number of dots, you basically multiply these two numbers together. So total number of dots here is 7 times 5, 35, 5 fours are 20, 3 threes are 9, and so on. So it will be p times q, p multiplied by q, and you have already calculated these values in terms of n. So p is n plus 1 and q is 2n minus 1. So if you want, you can open the bracket as well, or you can leave your answer in this form as well. So n plus 1 into 2n minus 1 will be the total number of dots in pattern n. Question number 21 is the diagram shows a triangle formed by joining the points A, B, and C. The equation of the line BC is given. Part A is the region inside triangle ABC is defined by three inequalities. One of these is 2x plus 3y is less than 32. So this inequality belongs to this line BC for which the equation is given. Write down the other two inequalities. So the other two boundaries for this triangle are this line. So this is a horizontal line because the y coordinate here is 2 for A and y coordinate here is 2 as well. So that means it passes through this point y equals to 2. So the equation of this line AB is y equals to 2. And since the shaded region is above this line, so your inequality will be y is greater than 2. And the other line is this line AC, and we have to find the equation of this line. So we know the 2 points on this line are A and C. So I can call the coordinates of A as x1 and y1, and let's call these x2 and y2. So to find the equation of this line, I can use the formula for the equation, which is y minus y1 equals to the gradient, which is y2 minus y1 over x2 minus x1 multiplied by x minus x1. So now let's substitute the values. Y1 is 2. So y minus 2 equals to y2 minus y1, which is 8 minus 2. 8 minus 2 divided by x2 minus x1, which is 4 minus 1. And then multiplied by x minus x1, which is 1. So this will be 6 over 3. So 6 divided by 3 will be 2. So this will be y minus 2 equals to 2 into x minus 1. So let me continue up here. So I'll take this 2 to the other side. So let me first open the bracket. Y equals to 2x minus 2. And then taking this 2 to the other side is plus 2. So plus 2 minus 2 is 0. So y equals to 2x. So this is the equation of the line AC. And since the region is below this line, so my inequality will be y is less than 2x. Part B is the point K7, where K is an integer, lies inside triangle ABC. Find the possible values of K. So the point which has coordinates K7 is inside the triangle ABC. So the Y coordinate is 7. So let me just erase this. So here we have C, which has coordinates 4 and 8. So if I draw a straight line to the y-axis, this will come here at 8. So 7 will be some here below. So if I draw again a straight line, so your point which has coordinates k and 7 will lie on this line, but since it is inside the triangle, So it can lie between these 2 points, right? So that it's inside. So if I draw a vertical line down towards the x-axis, so this is your range. Your values of k will be somewhere in between. So if I can find the boundary values, I can find the integer values in between. So to find this value, we know that this point here is on this line AC, which has equation y equals to 2x. So y equals to 2x. Here the y value is 7, and we have to find the x coordinate. So x will be 3.5. So this value here is 3.5. And then similarly, this point is on this line BC. So BC is 2x plus 3y equals to 32. So 2x plus 3, and again the y coordinate is 7. So 2x equals to 32 minus 21. This will be 111, and then x will be equals to uh, 5.5 here. So this boundary value here is 5.5. So now your k is between 3.5 and 5. So k is an integer, lies inside the triangle ABC. So it's an integer value and it lies between 3.5 and 5.5. So what are the two integer values on a number line which lie between 3.5 and 5.5? These are 4 and 5. So your boundary values are like this. So you have a number line here: 0, 1, 2, 3, 4, 5, 6. So the range of values is 3.5 till 5.5. But you're given that k can only be an integer. So the only two possible integer values inside this range is 4 and 5. Question number 22 is in the diagram A, B, C, D, E lie on the circle. So all these points are on the circumference. Center is O. This angle is given as 48 degree. This angle is 54 degree. First part is find angle X. So if you look at this triangle A, O, B, this is an isosceles triangle because OA and OB both are radius of the circle. So these two lengths OA and OB are equal because they are two radii of the circle. So if this angle is X, this is also X degree. So now we know all three angles of this triangle AOB, which is an isosceles triangle. So this will be X plus 48 should equal 180. 2x will be 180 minus 48, which is 140, 132. And then x will be 132 divided by 2, which is 66. So x here is 66 degrees. Part B is find y. So let me erase this. So this is the angle y, which is formed by this segment of the circle dB. So it forms this angle at the center of the circle, which is y. And the same segment forms this angle on the circumference of the circle. This is a straight line here. So we know that if the same segment forms an angle at the center and the same segment forms the angle on the circumference of the circle, the angle at center is twice the angle at the circumference. So y will be 2 into 54, which is 108. So y will be 108 degree. Part C is find z. So let's look at our diagram once again. Now this is our uh, angle z here. So if I now look at this quadrilateral B, C, D, and E, this is a cyclic quadrilateral because all four vertices of this quadrilateral are on the circumference of the circle. And we know that the opposite angles of a cyclic quadrilateral sum up to 180 degree. So z plus 54 will equal 180 degrees. So Z will be 180 minus 54, which is 126 degrees. So your Z angle is 126 degree. The next question is in the diagram, circles with center O and Q. So this is center and this is center of this larger circle touch at P, where OPQ is a straight line. So this is a straight line. The line ORT intersects the smaller circle at R and is a tangent to the larger circle at T. OR is 4 and RT is 6 centimeter. The radius of the larger circle is X centimeter. So this is the radius of the larger circle. Calculate the value of X. So if you look at this angle here, this is 90 degrees because this is an angle between the radius of the circle and this tangent ORT. So ORT is a tangent to the larger circle at T. So we know that the angle between a tangent and the radius of a circle is always 90 degrees. So this OTQ is a right angled triangle. And we are given that the radius of the smaller circle is 4. So this length OR is 4. That also means this length OP is also 4. So let me actually write it up there. And then since this is the radius QT is X, QP is also the radius of the larger circle. So this is X as well. So now if I look at this triangle OTQ, this is a right angled triangle and I can use the Pythagoras theorem to calculate the value of X. So let's do that. So I'll start writing here. Your hypotenuse is OQ. So OQ square should equal the base square, which is QT square, plus the height, perpendicular height is OT. So let's substitute the values. OQ square, OQ is X plus 4 square, and then QT is X, so this will be X square, plus OT is 6 plus 4, which is 10 square. So now let's solve this equation and find the value of X. So this will become X square plus 2AB, so 2 times 4, 8X, plus 4 square is 16, goes to X square plus 10 square is 100. So let's bring everything. So let me bring X square here. So this will be 8X equals to X square, then minus X square, this one, plus 100, and then minus 16. I'll bring 16 here as well. So this will be 0. 100 minus 16 will be 84. So 8x equals to 84. X equals to 84 divided by 8. I can cancel by 4. 4 2s are 8, 4 2, 4 1. So this is 21 divided by 2, which is 10.5 centimeters. So your value of X is 10.5 centimeter. Question number 24, you're given a matrix A. Find A square. So A square will be A times A. So A is 2, 1, minus 3, minus 2. And then again 2, 1, minus 3, minus 2. So I'll multiply this first row with this first column. So 2 will be multiplied by 2 plus 1 multiplied by minus 3. And then first row, second column, 2 times 1 is 2 plus 1 times minus 2. And then second row, first column, minus 3 into 2 plus minus 2 into minus 3. Minus 2 into minus 3. And then second row, second column, minus 3 into 1 plus minus 2 into minus 2. So 2 2s are 4. 4 minus 3 is 1. 2 1s are 2. Minus 2 0. Minus 6 plus 6, which is again 0. minus 3 plus 4. So this minus and minus become plus 4, and then minus 3 is 1. So your answer here is 1, 0, 0, 1, which is actually the identity matrix. Part B is the matrix X satisfies this equation. X multiplied by this matrix is equals to 0, 2. Find X. So if you look at this matrix, this one here, it's the same as here A given in the question. So this is actually A. So X times A is 0, 2. So to find X, I will multiply with A inverse on both sides. So A multiplied by A inverse, 0, 2 multiplied by A inverse. A and A inverse cancel out. So I get X equals to 0, 2 multiplied by A inverse. So now we have to find the inverse of matrix A, which we are given here. So we don't actually need to calculate this, because in first part we saw that when we multiply A with itself, we get the identity matrix. So whenever you multiply some matrix, let's say another matrix called C, and you multiply it by C inverse, you get the identity matrix. So here we are multiplying A with A and we get the identity. So that means A inverse is actually A as well. So the matrix A itself is the inverse, or matrix A is inverse of itself. And later I can also calculate A inverse and show that it's actually the same matrix A. But let me first solve it, and then I'll just for the sake of proof, I will show that as well. So 0, 2 multiplied by A inverse is actually A. So I can substitute the matrix A itself. So this is 2, 1, minus 3, minus 2. So this is a 1 by 2 matrix, 1 row, 2 columns. This is a 2 by 2 matrix. So column of first are the same as the row of the second matrix. So your answer will be a 1 by 2 matrix. So you multiply your first row with the first column. So 0 multiplied by 2 plus 2 multiplied by minus 3. And then your other value will be 0 multiplied by 1. And then 2 multiplied by minus 2 plus 2 multiplied by minus 2. So this is 0 plus and then minus 6. So 0 minus 6 is minus 6. And then this will be 0 and 2 times 2 minus 4. So for minus 4 plus 0 is minus 4. So your matrix X here is minus 6 minus 4. And now I can actually show that A inverse is actually A itself. So let's start with A. You're given A equals to 2, 1, minus 3, minus 2. So to find the inverse, you first need to calculate the determinant. So determinant of A is 2 multiplied by minus 2, AD minus BC, and then minus these two, 1 multiplied by minus 3. So this is minus 4, minus 3, and this will become plus 3. So minus 4 plus 3 is minus 1. So this is your determinant. So now to find A inverse, you do 1 over determinant of A multiplied by the adjugate of A. And adjugate is simply you swap the position of these two and you change the sign of these two values. So 1 over determinant of A is 1 over minus 1 multiplied by adjugate. Let's swap these position. This minus 2 comes here and this 2 goes here. And you change the sign of the other two. This becomes minus 1. This becomes plus 3. And this is minus 1. So when you multiply minus 1 inside, all the signs will change. So this will become 2, this will become 1, this will become minus 3, and this will become minus 2. So once you calculated A inverse, you got the same matrix, which is A, 2, 1, minus 3, minus 2, 2, 1, minus 3, minus 2. So if you want, you can actually calculate this as well. But from the first part, we saw that when we multiply A with itself, we get an identity matrix, which kind of shows that A matrix itself is the inverse of A. So that's how you will solve this question. So this is the end of paper 1 variant 2 for October November 2020.